Professor Zhang, thanks for your time. Thanks the opportunity to talk to you.
Obrigado.
Muito bom, muito bom. Professor, when I looking at your story, I find an interview to the Future Medicine magazine in 2018.
Oh.
You talk about you comment about the Britain chance.
Yes.
Our old friend, you, and in this interview, you tell me about this man. It is a great inspire you to keep going, to keep feel thankful to spirit of ecology. You think it's a what we need in the science? We needed the technicals thing. We needed the improve the technology. We needed discovery things, but the human is important too. Do you believe that? Yeah.
Yes. So, I miss Britain Chance. Quite a mentor. I can't believe it's 5 years since I've done that interview. So, I think what Britain Chance inspired me most is the inquisitive nature. Essentially, you have to be curious. Scientist has to be curious. Scientist has to be collaborative. It has to be the teamwork and the curious, really the question-driven nature is how we actually advance. Look back my career, I was very fortunate at the cancer center entire career, from Roswell Park to UPenn to Princess Margaret. It's in the environment I always have driven by the question raised by my clinical colleagues. So, addressed unmet clinical need is the number one in our mind. Then you have to really, you have a question, now you want answers, right? So you actually, for the work we do without so much discipline, truly multidisciplinary. Engineer, physicist, the biologist, the chemist, we're all working together. And I have even had the fortune to have clinician come as a graduate student. So that's, what Britain Chance really told us is the collaborations has no borders. The collaborations is not give or take. Right. It's really, a lot of people now thinking about collaboration is, will be my name on the authors. The first thing they think about. But really the collaboration should be, how can you gather the expert, the top of mind, best component, the people in the world doing and bring them all together. I mean, probably the best example is our recent collaboration with San Carlos group. Christina Vandley is just a classic example of Britain Chance and biosynthesis. We want to treat, Vandley had this vision to treat pneumonia by the non-invasive by lab. To make that happen, you have overcome so many barriers. So what we have done is we gather the best targeting people, Mark Vendel of Edinburgh Peptide, and the Netherlands group of nanobody. Surfactant, we have a very good surface chemistry, surface physics group from Paris Saclay, Professor Veronica. Then we have Christina on the antimicrobial, Vendel on the dosimetry side. Then we have our group doing the nano, doing the photosynthesizers, put them all together. And we were recently funded by the new CIHR grant to actually pursue the strain. So this is really, you have to, if you want to achieve the best, you have to work with the best, regardless this best is in your institute or not. You pursue, you find it, you work together, that you pursue that goal.
I get it. That's great.
Sorry, a long answer to a question,
because it's not simple thing.
Yeah.
When you work with, we started a student, graduate student, the people is usually fix on the techniques, fix just like, you forgot the collapse, forgot the human part.
Yeah.
What do you say is perfect? My second question is about the big challenge of the chemistry in the United States and difference in Latin America. Just a huge gap between this. What do you think about that? What do you see about that? How can you see the photochemistry rules happens?
I think you're underselling yourself. I think, in my mind, particularly in terms of photochemistry, photobiology used in photodynamic therapy, I would say Brazil is probably lead the world in the transform the photodynamic therapy from a niche therapy for FDA-approved therapy, but use such a small, limited use, transforming to mainstream. I think Brazil is leading the way. So I think I should correct yourself. That is, Latin America is not doing bad in this case. But of course, I think the second point, which is I really like what, especially Brazil, I don't know how much interaction with other countries yet. Now with my student go to Chile as professor, so I probably will know more about other part of Latin America. But if you look at Brazil, I was super impressed by the way they sending students for a year, for half a year, even for a year and a half to abroad, to many different countries in the world to student exchange students. This program very rarely exists in other countries, right? Meaning, so that is, without exchange, you can bring people in, you can start collaborations, but exchange is super important, right?
But in the United States it's different, like us, because I believe, for example, we have Professor Mauricio, speaking somehow. We have some Carlos, but not so much in Brazil. In Chile, we have one university looking for photochemistry. In Argentina, in Buenos Aires, probably one university looking for photochemistry. In the United States, in Canada, is everywhere.
Yes.
Is different ways to do science because we have different.
Well, I think yesterday I heard before my talk, right, there is a online video talk by the Pioneer Science Initiative. I think that's just a perfect example how you pursue that, right? And I'm fortunate enough, as you said, to have very productive collaboration with Brazilian colleagues, especially São Carlos group. And the way we did, in fact, actually recently we have a paper published, featured in the Encuentros, the German chemistry journal. It's featuring called Team Profile. And we call our team the Pan-America NanoBiophotonics team. And it's true, because it is from Canada, from Brazil, from Chile, and when Vanderlei go to Texas starting his own group, it will be really the Pan-America group, right? So the group started from my trip to São Carlos, my first visit to Brazil, which is 2019. And they have this biophotonic school, International Biophotonic School. They bring 100 students across Latin America into São Carlos for this meeting and bring all the international experts come in. And that kind of forum is truly amazing because I did a lecture on 3 straight days together with a lot of my colleagues. And that interaction, having such an intimate environment, we start a lot of this discussion with the student. We can start a true collaboration with the faculty. That's how I start with Brazilian collaborations, right? So after that, we actually our collaboration is a little different than most of the collaborations because we decide to have entire group meetings from 3 countries every 2 weeks, 1 hour, every 2 weeks, and go through every experimental finding details coming up. Not just the PI talk to PI student. PI is just, some people don't make it, it's fine, but we always have this meeting for 2 weeks. And that, probably one best example I can give you is when we try to make ICG emulsions for the sensitizer of the pneumonia, every sample we shipped from Toronto to St. Carlos, they no longer observe the fluorescence, no longer observe the photoreactivity. And we were surprised by it. And we couldn't, initially our goal is try to find out why. Then we find out, wow, it's because the ICG indocyanine green dimer, right? Chemically changed. Then what we do, instead of, crying foul, we couldn't make it work, we switch entire gear because we have so many people on the team, we decide to make them a photothermal and photoacoustic agent out photobleachable. That's why lead to that I'm going to here, right? So,
and I talked about this topic because we talk about students.
Yeah.
When these students come to the lab, you must be looking the technical things. If I can do the experiment, can do the study or not. But just not that. Like the human part. When you look into, when I talk with your student, what are you looking in and try to find if you have a chance?
Yeah.
To
So the first thing I'm looking for is student is, I'm looking for a student who is passionate, is driven, because you can teach that, they're driven or not, right? So this ball,
it's not wrong.
yeah, no, that's a huge problem. I mean, the technology is you can be trained, but you can teach how driven a student is. And I have my fortune to have a few of the students from Brazil in my lab. Absolutely driven. So driven is number one. Right? If you don't have a passion for science, there's no chance, Lord, right? No chance. And second, when I found this is coming from Brazil, from Asia, particularly Brazil to some extent. Students are not as confident, and they like to listen. They like to. It's hard for them to challenging the authority.
Mm-hmm.
Right, the culture and the thing they just want to obey, but it's getting better. But what I'm always trying to do is cultivate the first thing I'm looking for is, train them to be confident, train them to be, not afraid of to speak out, right? Need to be proactive, because then, then they start.
You can do what I need.
Yeah, it's just, you have to have not just the passion, you also have certain, maybe what's the right word? Fearless.
Okay.
You have to be a fearless to become a good scientist. You can't be like, this is my boundary, this is something, I don't understand this. You have to have no fear.
About the future.
Right.
My last question is about the future. How you see the future of the chemistry, photobiology on the world? How you see this?
Future is bright, super bright.
Really?
Yeah, I see a completely rechange. The field is going through a rekindle. It's interesting. A lot of people are jumping in this field. The field has been staggering for a long time, and that's no question. But I think the field is starting to become tremendously getting more interesting. First of all, the word of theranostics, I'm more talking about therapeutic side for the photobiologies. The word of theranostics is when people, all the material science people, everybody jump in to make a new material which is representing brand new class of like photosynthetic points, no longer just all the inorganic materials or the metal materials, and they are starting to come along beautifully. And everybody trying to bring the material into the world of initially it's on the diagnosed side. Now everybody wants to theranostic. So the wild effect of the good field is so many material people, bioengineering people, are not interested in photochemistry. So you will see the field expanding dramatically. New people, new field, new knowledge bring to completely new blood. So that's what I see. I think that's one of the issues with staggering for a while. Two, the immunology side. The photoimmune side, if you use the Brian Wilson's term, he wants to term it photochemical immune stimulation. People call it photoimmune therapy, but there's a term is so confusing. People using it liberally for everything. But one thing is no denying. I went to the Finland for the IPA meeting in Zheng. Almost half of the conference is on immune response. Because that, you mean the most important thing is the photodiene therapy per se is a local disease control. But when you are starting to have immune, you're talking about moving from transform a phototherapy from local disease control into disseminated disease, metastatic disease. Now you're talking about beyond local, right? That's one, getting everybody's, when you have a chance to really stand. The final point I want to say is beyond light, right? If you look at the broad line, what is light? Is light is only opticals? X-ray is light, right? A lot of things are light. Right? If you're looking at broad context, the light can be activation of phototherapy is activation molecule by light. If you think this light broader, X-ray is light.
You talk about
So there are so many people are starting working on, can you push the boundary of the beyond the light limit? Now all of a sudden, you don't need a fiber to deliver light. You can using the non-invasive light, right? So beyond light, beyond local, and with all the new material rush to join the photochemistry, photobiology, the future is super. That would be my assessment.
That's great. You really have to listen to that because. So, okay, this is I just have to say thank you. Come here to Brazil to talk about your job, about your works, your researches, and give your time to us.
Sorry about the rambling, but really glad to talk about this.
Muito bem, gente. Muito obrigado. E se vê na próxima.
Obrigado.
Obrigado, professor.